This is a video for AQA Further Pure Mathematics, Calculus section 4.5, where we're looking at integration using partial fractions where the denominator has a quadratic factor of the form cx squared plus d. So remember then that we're using this process of partial fractions to take algebraic fractions and create something which can be integrated by splitting it into separate parts. The example I want to look at is this one here, because this time we've got a quadratic factor here. So remember that when we split this into partial fractions, the expression will be a over x plus 1 plus bx plus c over x squared plus 3. We've seen in a previous video that the partial fraction values, the constants a, b and c, turn out to be a is equal to 1, b is equal to -1 and c is equal to 2. By all means, go through and check that for yourselves again. But this means that we can write the expression in the integral as 1 over x plus 1, and then taking the x term, then minus x over x squared plus 3 and plus 2 over x squared plus 3. And therefore the integral that we have, the integral of x plus 5 over x plus 1 x squared plus 3 dx must be the same as the integral of each of these parts. Now we can see that we've got three separate parts, all of different nature to these. This first one here is going to be a log integral. The second one is essentially a form where we've got f dashed x on the top line and f of x on the bottom line. So we're looking for the fact that we can differentiate this bottom line here to give us the top line, and we'll look at exactly how we do that in a second. And finally, we've got something which is a standard integral where we've got the form of 1 over a squared plus x squared. So this is a standard integral which is of the form arctan. So the partial fraction work has given us the result here. And so now integrating each of these parts, the first one is just straightforward natural logarithm, so logarithm of x plus 1. And then we've got something which has got to be integrated using the fact that it's f of x on the bottom line, f dashed x on the top line. So we'll need a factor of a half going into there. So we'll get minus 1/2, and then a logarithm of the denominator, which is x squared plus 3. I'll write that with the moduli rounded. And then finally, this is a standard integral arctan, where a here is equal to root 3. So it's arctan of a squared plus x squared. And therefore we have 2 from the top line, and then the integral is 1 over a, which is 1 over root 3, and then arctan of x over a, so arctan x over root 3 plus c. Now we could combine the two logarithms. The -1/2 means that we're going to have square root of the x squared plus 3 and then divided by. So we can, putting the two logarithms together, logarithm of x plus 1, the top line, and then the bottom line will be the square root of x squared plus 3. And then 2 over root 3 arctan of x over root 3 plus c. So quite a complex answer there, but as you notice that each individual part is relatively straightforward using known results from previous work. Natural logarithm. The second one was of the form f dashed x over f of x, so logarithm of f of x. And then finally, standard integral using arctan. So we've now covered all of the different situations that you might meet with partial fractions. So in summary, remember you must first of all check the denominator is a higher power than the numerator. If not, you can divide, and that will produce an expression plus an algebraic fraction, which you can split into separate partial fractions. Once you've done that, the integral is in parts, each of which will have a solution that you can find quite straightforwardly. Often logarithmic integrals, however not always, particularly if you've got a quadratic factor, you may end up with things which are arctan, as in the last example. The logarithms, if they appear, can be combined into a single logarithm. However, it's not necessary to do so unless there's a particular reason. For example, a question asks for it in a particular form.